Okay, so in our last class, we started with the command for installing Numpy, which is pip install. After installing your Numpy, you have to import it so that you can use it. Then we also had an example of how to convert a list to an array, and also how to manipulate that list. In this case is whereby you are to configure the number of rows and columns, be specific, and have maybe a specific number that you want to form the matrix. And also we had a custom array. Also looked at the attributes, which is print, which is the print for the shape, so that you can know how the shape of the array, the number of rows and columns. Also looked at the size, which carries the total number of elements in the array. Yeah. And then I gave you an assignment of how to use the np.min, np.max, np.min. If anyone has a question on the assignment, you will just inbox me so that I can assist further. So today we start with subset in Numpy. First. In Numpy, subset refers to a smaller portion or selection of elements from an array. It refers to the smaller portion or selection of elements from an array. And also, Numpy provides various methods to create subsets, which is indexing. There is a conditional. There is another one called fancy indexing. On specific conditions, indices, and logic operations, we have common ways that also you can use to create your subsets in Numpy. Okay. So, like I told you guys before, start by connecting your notebook that can be assigned a disk and RAM in the cloud. After doing so, in order to use Numpy in Python, first you have to import the Numpy library. So we import Numpy np. In this case, we can name like the array that you want to form. Can name it as can have it as first. Okay. I want a difficult or a long word. Can have it as did we use R? Yes, we did use R1. Did we use R1? No, I didn't. Okay. R1 is equals to np dot array. Yes, question. Someone has a question, font. Okay. Let me do this first. I think now it's okay. Then we can have our 1, 2, 3, 4, maybe 5, huh? 5, huh? And then now we come here and now have our subset, which is R1. R1. Then you define now the portion that you want to slice. Subsets are similar to slicing. I can say that. Maybe you can give it 1, 2, 4. The array. Then print and print our subset. Okay. And now we can get this 2, 3, 4. Start indexing from 0. So our 1 will be 2. Our 3 will be 3. Then our 4 will be 4. No, our 2 will be 3. Then our 3 will be 4. Because you start from 0. So now we move to conditional subset. In this case is whereby a subset will only work if the condition is true. Okay. In Numpy also allows you to use logic operators like the greater than, the less than, equal to, greater than or equal to, less than or equal to create Boolean arrays, which we're going to use now here. Like for example, I can choose to use the greater than, so that if it satisfies the condition, then the Boolean array can filter the original array. So if our original array, let's say R2, R2, which is equals to my there. Okay, which is equals to np dot array, and you can have it as let's have it as same 1, 2, 3, 4, 6, 7. No, I'm getting that error. Indentation. Okay. Now for the now this first array to be filtered, now you have to come in with a condition. You can say condition is equals to R2, let's say greater than, in that case, let's say greater than 4. So if this condition in our array will be true, then it will have to print the numbers after 4, because now in this case is that if the elements in the array are greater than 4, print them. So now we can come here and say like our subset will be R2, then the condition. And the condition, that's the syntax. Then you can call our subset. And you can call our subset so that you can get 5, 6, 7. A question up to that point? Any question? Okay. Now I also mentioned about the last one, which I said it's a fancy indexing. Fancy indexing just allows you to create subset by passing an array or a list of indices to access. So in this case now, you'll have to specify the indices whereby the elements are being stored. Let me do it here. We can say 3. Now 3 is equals to np dot array. Then we can have it as the same. Let's do just numbers. 5. Then now, if you're doing that now, instead of unlike the conditional subset, now you'll have to specify now the indices where the elements that you want to retrieve are stored, which is equals to np dot array. Then we can have it as and the elements are being stored at let's retrieve for 0, for 1, and maybe for 0, 1, maybe 4. No, now I have to again now store the indices in my subset, which is equal to subset is equals to R3 indices. Now this one right here, so that it can filter here. Okay. Then now print my subset. Then I'll get now at index 0 the value stored is 1. At index 1 the value stored, the element is 2, and at index 4, which is 0, 1, 2, 3, 4. Now you look at the back here, because it doesn't print the same one. It gets the previous element of the array, or list, or when you're slicing. For example, at least when you are slicing hello world, yeah, such scenarios. Any question with the subset before moving to slicing in Numpy? It's the same the way that we were doing in the case of the lists and all, but now the concept are a little bit twisted kidogo. A question, anyone? Yes, Brenda.
Yes, Tony, I lost my network.
Mm-hmm.
Will you kindly repeat?
Where? At which
Fancy
cell?
indexing.
Or fancy indexing?
Yes.
Okay. Is your network okay now? Brenda?
Not yet, Tony, so I'm using my phone's network.
Oh, sawa. I can just continue, Cynthia?
Yes.
Okay. I started by first defining our array, which I just took np dot array, np dot array, not the fonts, like parentheses. First, and then I said it was just 1, 2, 3, 4, 5, 6, 7, maybe now. After doing that, now, like in the case of now fancy indexing, is it has to satisfy like a given requirement, unlike in this unlike in the conditional subset, whereby it was a condition whereby if the elements in the array were greater than 4, it will have to subset the array and then print the array. Now in this condition is whereby you give the indices that want to be printed out when they'll be stored in your subset. Now the indices is whereby like in this case, now we start counting the indices from 0, which is indexing. Like now at index 0 we have element 1, index 1 we have element 2, 2 we have element 3, 3 we have element 4, 4 we have element 5, 5 we have element 6, and 6 we have element 7. So you start first by defining your indices first. It will be indices is equals to np dot array. Then now you give the specific indices whereby the elements will be stored in your subset. Now you come here and also now you have to define your subset, which is equals to R3, and then where you had stored your indices that you want to be printed. Then now you print. Now print the subset to get the result. And that's it. Umeelewa Brenda?
Yes, nimeelewa, thanks.
So now we move on to slicing. Slicing here now we can, it's the same. The concept is just the same. It's now in Numpy you are handling arrays, but the concept is the same from what we've been doing before. So you can start by, let's say, create an array, which is a comment. Then we can create an array like np1. np1 is equals to np dot. Now here we are creating the array. Is equals to the syntax of creating an array. You have to keep notice this one. Then the elements will be in between. The elements will be in between the box brackets. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 8. Okay. We have to close it. Okay. After printing it, we can decide and call it so that we can view it. Now this is our one-dimensional array, and then we can decide to slice. We can decide to slice the array np1. Slicing is whereby I love to give some sort of like a range of whereby I want a range of indices whereby I want it to be sliced from. So you can say here like we can come here and say print np1, the one that you want to slice in the range of let's say from 1 full colon to 5. It won't print the 5 value at the end, the one that I taught you about start. Now 1 is the start, 5 is the end, then later on I'll introduce the stepping, but it won't print the 5, it will print now the previous one. So now we'll get is 2, 3, 4, 5. So because you're starting from 0, 0, 1, 2, 3, 4, 5. Okay, so what if we want to return a specific x index of an element? Yes, we could just say that Mm, print. You have to specify the type of die, which is NP1. Then you have to give your range, maybe it's 2 to print that is in 2. You get that one. Maybe want to, again, another one is want to return all the elements from a start, from a specific start. You can say a specific start to end. From a specific start here, maybe we can say from 2 to the end. Just copy that code. Then from 2 to the end, I told you when you don't want to specify like maybe the first and the end, you just put a full colon and leave it blank. So it has started from 2 to the end. So 0, 1, 2. 2 is from 3 to the end up to 7. Question before I introduce the stepping? Anyone? Yes. Kuna swali? Okay. Before we move to the next, I can say maybe slicing negative. Slicing from negative. Can say let's slice maybe from -2 to, let's say, -7. Yes. So start from the back. Now we are out of range, but we're getting a message to -5. Why am I getting an error? Yes, I was doing it the inverse way. From -5, what's -2? Why not? Maybe -1. Oh. Any question up to that point? Okay, stepping in Numpy array. It's the same concept. The same concept. You have to print MP1, and we give our range and our step. So we can leave it blank, but we want to step it not 2 steps. We run code. By leaving it blank, I'm telling it now from the start to the end because I'm not specifying. If I was to specify, I can specify this way. Then I can say from index 1 to index 7. That's the start and the end, those steps. Ephraim. Yes, Brenda. Ephraim, mute. Brenda, yes.
Okay, I wanted to ask a question.
Mm.
When you talk of stepping
Mm.
in Numpy array, okay,
Mm.
what are you talking about? Because I've
Mm.
not really understood.
But it's the same now when we were stepping maybe a list of numbers. It's the same concept. Did you understand the slicing that we did before?
No, I had issues.
You still had issue. Nilikwambia uende upitie alafu urudi kwa my inbox huku hairudi because you're the one who made us to move forward to the conditional statements. Bado you didn't get it bado. Sawa, let me explain it again na ina shida. So stepping now, okay. Now let me print in P1. Now this is our array, sindio? This is element 1, element 2, element 3, element 4, element 5, element 6, element 7. Now indexing start from 0, meaning the 1 will take 0, 2 will take 1, 3 will take 2, 4 will take 3, 5 will take 4, 6 will take 5, and 7 will take 6. Now what we're telling, now for this example, we're supposed to slice it from 1 to 7, meaning our 1 is 0, but our 2 is the 1. Now we have to start from the 1. But we're stepping with 2, meaning this 1 plus the 2, you'll get 3. Now we'll have to move to index 4. Element 4, which is in index 4. Which is in index 3, I mean, because we came from 1 plus. Vanessa told us that the sequence in the next number, whereby unaangalia sequence and you see like the difference in between now. Mona. So, but in this case now, 1 is in index 0, 2 is index 1. Now we are stepping by 2. So we have to add here, now the index 1 plus 2, which is our step. The total that we'll get here now in our case is 3. Now again, na tena unaanza kuhesabu 0, 1, 2, 3, meaning iliangukia at 4. So our next will be 4. Now here we are at 0, 1, 2, 3. And then you add 2. You'll get 5. This is at 3, this is at 4, this is at 5. Now the next will be element number 6, which is 6 here. Up to that point, Kwamboka.
In the last part, why did we add a 2?
See, we are stepping again from 4. Getting our next step goes hatujamaliza range. Range inaanza from 1 to 7. This is 0, 1, 2, 3, 4, 5, 6. Because if I gave out 6, it will give me up to this range of 6. Now, at this point, I told you at the end, you have to subtract 1 so that you can get the previous number or the previous element. Because now here, if we say 6, unaona, tutapatia hadi hapo. So you have to add 1 there so that ndio kuwe na range mzuri. Have you get mbona nili add 2? Because you are stepping by 2. You take another 2 steps by adding to the current index element, which will be 0 or 1 or 2. Una add hapo ndo unajua the next index kwenye unasimamia, that's the value that you should be printing, or the element that you should be printing in this case.
That's okay, Tony. Let's continue.
Umeelewa kwanza? Bado tena itakuhaunt mbele. Tunaona vile tulitoka huko nyuma tena imekuja mbele. Umeelewa kwanza? Kumbuka. Hello.
Okay, I don't know why I'm having a problem with this slicing. Juu 1 minute naelewa, the next minute ni kama nasahau.
Okay. Nani ameelewa atusaidie kuexplain? Yes, Claire. Please help us. Yes,
Good
Claire.
evening.
Good evening.
Okay, Kwamboka, are you with me?
Yes.
Tumepatiwa hapo array 1 to 7. Unaandika hiyo 1 to 7, alafu walisema indexing in Python starts from 0 ukiendelea. So ukishaandika namba zako 1 2 3 up to 7, hapo chini unaandika 0 1 2 3 ukiendelea hadi penye last digit yako iko. Tuko pamoja from there.
Yes.
Now hapa tumepatiwa 1 to 7 to 2 in a step by 2. 2 is our step. Alafu our first value is 1 where
Claire, wait. Tumejuaje tunafaa kustep by 2?
okay. Hata sijui nikuexplaineaje. I guess ni formula tu from the previous class, the last video ya kustep. Yeah. So our
Kumbuka,
first
Yes.
stepping tumeidefine hapa, ndio hii stepping yetu, because the syntax the syntax is supposed to be start, stop,
yeah, step.
stop, so you know up to there, then step. The syntax is this one. So whatever number utapeana hapa katikati ndio ita step. If it's 1 ita step. For example, if you add 1 of which is the same like itatupatia the whole index vile, the whole array vile iko, so unaona? If it's 1, unaona? If you're stepping by maybe 3, it will give you all this 2 and 5. If you're stepping by 4, I think we will be out of range sasa. No. Search. Hivyo sasa. Because we are starting from 1, tunaenda part, we are stopping at 7. But in between here, we are slicing some of the elements between the range of 1 to 7 by stepping by the number of which you want. Maybe 3, maybe 4. Yeah. Because again now, hizi elements zenye ziko between 2 up to 7 zinakuwa sliced, and the way to slice them is by stepping, kuziruka.
Tunaweza endelea sasa.
Umeendelea.
Okay. Sasa our first value which is 1, ukiangalia kwa indexing our imeanza 1 2 3, so 0 is 1, our 1 is 2, so una note down 2. Alafu so since in a step by 2 itakuwa 1 plus 2 itafika kwa index 3. So unaangalia index 3 value yake ni gani? Ni 4. You note down 4. The next step itakuwa 3 plus 2 you get 5. 5 index 5 value yake hapo juu ni 6. You note 6. Alafu unakuwa umemaliza. Umeelewa?
Sijui niseme ama sijui niseme hapana. But me, I think I just have a
Formula.
problem with this slicing.
Okay.
Okay.
So how do you think we can help you? Unaona aje? Weekend. So that I can focus on you peke yake.
Yeah, tunaweza tafuta time.
Yeah, you look for me anytime. Ukaniambia tu like prior ndio ni plan. Then I can I'll share screen alafu nita scribble sasa juu ndio we get to be on the same page.
Aye, poa.
No. Okay. So you can also have a multi-dimensional array. So whereby maybe you have a 2D, a 3D, a 1D. An example of the 1D ni kama hiyo tumekuwa tukifanya hapa. Like this one, this is a 1D. And for you kutaka kuprove which type of array it is, you can just come here and say it was NP1, and say NP1 is equals to np dot array np dot array no, because I'm supposed to use the dot ndim and I'm calling it, so print supposed to call it first print np1 dot ndim. Ndim is the, I'll say it's the function for knowing, and it will tell you whether it's a 1D, a 2D. Yeah, so this is 1. So let me explain it further now with code. We can create another one. Semegani np2. We'll go to the array. We'll pick array 4, array 3, R3. We'll say R4 np dot array from our array here. 2, 3, 4, 5, 6, 7, 8, 9, maybe 10, and 11. Okay. So we'll on up to that point. I'm getting another error here. Syntax. Yes. Okay. I want to create nishaonyesha ya kwanza. Let me create a 2D array. 2D. 2D. Then let me reduce faster the number of columns so that we can handle comma. Come here. Put another one. Maybe we reach that. 5, 6, 7, 8. And those 1, 3, 4. Yes, sir. I can have another comma. And I can have another one. No. You can have 9 and 11, 12. Yes. An array. So I'm going to enclose them all. It's good now. And for us to determine which type of array is this one, be sure that's a 2D. Come here and say R4. What can know? The 2D. So a 3D will have, let's say, 2 layers. A 3D one. We can have the same R5. 5 layers. Equals to empty dot array. Then start forming the array. Is my screen visible? I think my net, you come on my internet yangu. Anyone to confirm? 1, 2, 3, 4. I have to store it fast and move to the next whereby lab 5, maybe 6, 7, 8. No. Then I'll have to have another one is, let's say 9, 10, 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. Hello?
Hello.
Yes. Mnaona screen
Iko
yangu? I feel like I'm
iko
lagging.
sawa.
Iko sawa?
Iko sawa on my
On my
end.
side, on my side I feel like it's lagging. Anyone else? Okay, sawa. Okay. Then we create again another set of an array, which is mm, we open another one and closed. Let's say 10. These are just random numbers I'm taking. You can take of your choice. You separate it. We can have, let's say, 1 again, 2, 3. Is it 4 columns? 4. Yes. Oh, I'm getting an error, but I'll sort it. Kishamaliza. Then we can have another one, which may be maybe 16, 13, 14. We may need this one first. Yes, sir. So this is one. Yeah. Error. Okay. So let me first. Yeah, which I closed here. Should be closed. Should be closed here. We open another one. We closed it here. And the overall now, which is also should be, yeah. You can identify the error.
It's the 9 there, yeah. That is,
Mmeiona. Ingine mnaona ni gani? Hii si imefungwa hapa chini. Hii imefungwa hapa. Having an error. Turn it on neon here again. Closing parenthesis where? At 14.
Where there
Closing
is
parenthesis.
10, 23, they are double parentheses.
Yeah, that's another layer. That's another layer to make it a 3D. That one is okay. Yeah. So it's saying closing parenthesis does not match opening parenthesis. Okay. At here. Yeah. Does not match why. No, I think it should be okay. Oh. You can see the error tena. Tuambie. Mimi sioni. They're here and here.
Okay, may I have a question?
Yes.
Why is the first row 1 to 4, the second one 5 to 6, then the third one is 9 to 11?
You can have any number in between
Any
there.
number?
Any vile
Yes.
unataka. I chose this one ndio ikuwe rahisi for us.
No, like the others are 4 values, then the other one is 3.
Oh, okay. Zinafaa kuwa equal number of rows and columns. 1, 2, 3, 4. 1, 2, 3, 4. 3. Okay. Maybe that could be the error. Okay, up I used full stops instead of commas. I think si imeenda? I think it was the full stops, no commas. No, it's giving me a warning bado. Because if I print it, print R5. No, and it's not supposed to give me such an output. Only dent. That closed. No, this one and that one.
The last row, Tony, still has 3 elements.
This one. One of 12. Yes, hivi sasa. Thank you. Then now we can decide to know if it's a 3D. We can decide to know if it's a 3D. Let's say assigned it as R5. Have you guys seen this syntax here? But if it's the type of dimension your array is, it's a 3D if you get the number 3. I think we are getting the errors juu sikuwa nime balance number of rows and the number of columns in each array. Thank you. Question?
Tony, me, I have a question.
Yeah, uliza.
The first code that we wrote and this one, the one we identify this array as a 2 array and this one as a
2D.
3 array.
Mm.
It's based on what? So that when I look at an array like this, I'm able to know this is a 2 array, a 3 array.
Oh,
Because me, I'm just seeing like you are just writing numbers and I'm not.
wale. Unaona kwa 1D, one dimensional. So unaona vile inakaa the structure of it.
Hiyo najua.
Haya, ukikuja kwa 2 dimensional umeona vile inakaa. Iko na more than, let's say, 2 rows.
2 rows.
You know how rows are? 1, that's a 1 row. 2. Yeah. How I understand it is like a one dimensional. That's why I always confirm. That's why nimepatia hii code hapa ya ku always confirm which type it is. Because in, like, let's say 3D, you see it's a set of 2 arrays in one array. Because unaweza ona hapa niliform an array, this is another array, this is another array, but it's enclosed in this first array. Alafu kuna another array which is enclosed in another array. Ukiona hapa sasa, ukiona hapa kuna 2 layers. There are 2 layers now here. Make it a 3D. There are 2 layers. And here we have only 1 layer. No, see layer ya kwanza, this is the last array of the first layer. Then I started another layer here. Which is enclosed here sasa. Si ndio iko enclosed hapa.
Sisi mimi mnaweza count niseme ni 2.
Hapana. Huwezi count hivyo.
Kama unaenda hivyo then mimi nitasema juu hiyo ya kwanza imeanza hapa ikaishia hapa. Sasa nitasema ni 2.
But okay, Kenya najuanga up to 3D from my own experience, inakuanga na 2 layers. Inakuanga na 2 layers. Layer ya kwanza ndio unaona imeanzia hapa. Okay, ona. Si syntax ya kuform array ndio imeanzia hapa. This one. Si ndio? Ndio ikamalizikia hapa. Meaning whatever that is inside here is one array which is R5. Umeona? So we started by forming the first array which has a list of different lists zake. List of different elements. Alafu tukaifungia hapa. Umeona? So since we are
Okay.
going to form another array, si ndio the first array ndio hiyo ishakuwa hadi hapo, si ndio? Tukaifungia hapa, umeona? So we have to
Yes.
put another comma so that we can continue and form another array, which is this one that tena nitaanza alafu nitafunga hapa tena zote hivi tena, alafu nitafunga, alafu nitafunga na ile parenthesis nilitumia huko hapo, ndio utajua. But kama unajishuku, you just use this one here,
Okay.
alafu utajua. It will tell you it's a 3, it's a 2D or it's a 1D. But a 1D inaonekananga tu. Unaona 1D vile inakaa. Unaona? Na 2D. 2D tu iko na layer tu moja. But 3D iko na layers mbili. This is the first one from here up to here. And this is the second one from here up to here. And keep note of the number of columns in each element of the arrays. You know, because I wasn't keeping note, that's why it kept on giving me the errors. Na layers zinakuwa separated by a comma. Ndio comma hapa.
Me, I thought the reason is why I didn't think it could be an error. Me, I thought maybe that is how a 3D or a 2D is.
No, it's different for the arrays. Sasa hapa tukienda mbele, whereby we're manipulating data is whereby you can extract like a specific column. Unaona, you can extract, let's say, from here. Yani, let me put it down. So let's say tunataka extract maybe the first row peke yake. So we can come here and say, like in this case now here, we can take the R4. Tuchukue the R4 to extract only the first row. Extract the first row. Then this is our array. We want to extract the first row. Run it first. Alafu tutakuja tu tuseme subset is equals to R4. We give the range of our row. The range maybe tuseme, we say the first, ndio 1. Now the comma, alafu full colon, I mean. Then we print the subset. Tuone kama tutapata 2 only. Tunaona 5, 6, 7, 8. This is the row. Umeona? Because the indexing tulikwambia it start from 0. So this is the 0 row. This is the first row. This is the second row for our matrix. So
Yes,
so
that's
for this,
okay.
so for this, the syntax, so for this, the syntax yako itakuwa maybe, let's say, the syntax will be row stroke column. Yes, let me have say syntax. Row and column. I left it blank because I want only the first peke yake. But if I want now, let's say a column, I can just take this one. It's the same thing. Interchange too. Maybe nataka pia the first column will be 1. Then I'll have my full column. Then I'll have the first column. Which is 2, 6, 10. 2, 6, 10. Ndio 2, 6, 10. Because this is 0, 1, 2, 3. So 2, 6, 10. So in the case whereby maybe nisiwa confused, let me add hapo even ndio zikuwe in a line. Let me add some numbers. Maybe I can have this one as 11 again. Zikuwe in line. You can put this one as 81, ishikane kidogo. 23. Maybe 61. And there. You can come and run here. So 23, 61, 10. 23, 61, 10. This is our first row. Hivi. because indexing starts from 0 0. If you could have left it let's say at 2, column 2 ndio itakupatia hivi 23 11 11, maybe column 3 yeah 4 81 12. Nimekujibu
Yes.
ama confuse even more? But I
Hapana.
was going there. I was going there hapo kwa rows and columns either way. I was to cover it. Yes?
Ana niko sawa.
Uko sawa? Kwamboka uko aje?
Yeah.
It's you who asked the question.
I was the one.
Okay, sawa. Umeelewa sasa? Aya. Okay. So you can do a comparison of NumPy and lists, Python list. Muliona tu vizuri Python list and NumPy they are both data structures used in Python for storing and manipulating collections of values. However, they have some key differences in terms of functionality, performance, and usage. For example, if compare functionality of list, it's like Python list is versatile and can store elements of different data types. They also support dynamic resizing, can be nested, allow for flexible manipulation and operations. But for NumPy, they are homogeneous, meaning they store elements of the same data type. So kwa NumPy huwezi anza kuweka string na integer, you can't. They provide a wide range of mathematical operations and functions optimized for numerical computations. NumPy arrays they are also fixed size when created, which leads to efficient memory usage and fast execution of operations. Okay. So also a thing to note is that Python lists offer flexibility. Their performance can be slower compared to NumPy arrays, especially when performing operations on large data sets. NumPy arrays are designed to be highly efficient for numerical computations. So you can keep note of the lists, the difference between the list, Python list, and NumPy. And also a thing to note is that for the Python list, their syntax is straightforward and familiar. So we were using the square brackets, or using like the list constructor. But for NumPy, they are provided by the NumPy library and their own syntax and functions. Sawa. So in summary, what I can say about the difference between the Python and the NumPy, the Python list and the NumPy arrays is that Python lists are more versatile, suitable for general purpose programming, while NumPy are specialized for numerical computations. That's why you see I've only focused with numbers everywhere. This is because they offer improved performances and wide range of mathematical operations. For example, if you're working with a large data set of performing numerical computations, NumPy arrays are the preferred efficiency. That's what I can recommend. But they require flexibility and support for different data types. So Python list may be more suitable. It depends on how you want to work with it. So, okay. A question up to that point. So you can note down the matrix operations. So most of the part of the addition and the subtraction. If you have anything else, you can always reach out to me. So Mm. I can maybe show you like kama let's say the addition one. Whereby you have to create like a matrix, then you have to maybe even find the inverse. So wacha mtanishow, wacha ikwe to assignment, and please keep note of the assignment. If you have any issue, just reach out to me. So I will add some notes kwa hii the current notebook, alafu I'll send it later. I'll make it more nicer than this draft, alafu ndatuma a more detailed one.
You can also include the assignment at the end of
Yeah,
the notebook.
I will, yeah, sure, I'll do so. Nafanya hivyo. You'll get it at maybe 10. And add some few notes for better understanding, then I'll send it.